Hello students, today now we are going to learn a very important topic, that is electric potential energy. Okay, we have discussed already what is potential energy. It is energy possessed by virtue of its position. We have taken the example of hammer. When you are raising the hammer, the potential energy stored inside that hammer is due to its position. The higher it is raised, the higher the potential energy it will contain. In short, what it wants to say, that the system is the potential energy is due to the virtue of its position. Here also the energy possessed by system of charges by the virtue of its position. Two important things, one is position and second is system of charges. There cannot be potential energy for one charge. For one charge there cannot be any potential energy. Potential energy is always for system of charges. Suppose let us say we have Q and Q, two charges. This is system of two charges. This will possess some potential energy. Okay, suppose this Q and Q. This is again a system. This will also possess potential energy. Now the energy required from bringing this configuration to this configuration, or from this configuration to this configuration, is your potential energy, because the work is needed to be done against the electrostatic force, or the work done to bring this configuration from 1 to 2. Suppose this is 1 and 2. The amount of work done from bringing the configuration 1 from 2 or from 2 to 1, both sides, you can go either way, is known as your electric potential energy. That is due to the virtue of distance. Suppose here it is r distance and here it is capital R distance. So you need to do some work on it, and this is your nothing but potential energy. Okay. Now let us understand how to bring the configuration. Suppose I have two charges, both are at infinity. Okay, I have two charges and both are at infinity, and there is no electric field, any electric field generated due to any charge currently. Okay, so to bring a charge from infinity, I will bring a single charge. I have a single charge and I will bring that charge to point P1. Okay, I will bring a charge to point P1. Then what will be the work required? The work, just you can stop and imagine. If I say work done to bring charge Q1 to point P1 will be equal to 0. You will think how it will be 0. Now suppose I tell you are in a space. Okay, you are in a space. Then what is the amount of work required to move you from one place to another if there is no gravitational force acting on it? The work done required will be 0, because there is no gravitation acting on it. So work done will be 0. Similarly here, initially when there is no electric field, mark my words, at that time you can bring a charge from anywhere in the space from infinity to any point without having external work. Okay, so this will be a charge. Now if you want to know the potential of this charge, I am not saying potential energy, potential due to this charge at point P2, you have already studied about it. Then what will be the potential if there is at distance r? So V1 will be equal to KQ by R. Okay, I hope you all know this. This is the formula which you have studied for the potential due to a charge. Now what I want to do, I want to bring another charge. Suppose Q2, there is a Q2 charge at infinity. Now I want to bring that charge up to point P2 sorry. Okay, so what I need to do, I need to work against the field, because electric field of this will be in the repulsive force due to Q1 and Q2 are both are of equal charges. That is, equal means like charges. So it will repel. So I need to work against the electrostatic force of this charge to bring that charge from infinity to a point. So what I will do, I will do some external work. Okay, what my external work will be equal to? Potential into charge. Okay, you know what is potential? It is work done by external agent per charge. Okay, so from this formula we can write this. Okay, so I'll rubbing this. So here the potential is due to this charge, so I can write V1, and the charge coming will be Q2. So I can write it in this manner. V1, you know, KQ1 upon R, and this will be Q2. Okay, so the work done by external agent in bringing the charge Q from infinity to point P2 will be equal to K Q1 Q2 by R. We can write this as W2 also, that is work done for bringing charge 2. Okay, So now to know the total potential energy of any system is the total work done to bring the system of charges in any configuration. So we can write work done for bringing the charge 1 and work done for bringing the charge 2. So it will be equal to, we know W1 is equals to 0 and W2 will be equal to K Q1 Q2 by R. So the total potential energy of the system will be equals to K Q1 Q2 by R. Okay, this is a formula for potential energy for the system of two charges. I hope this is clear to you. Okay, so we'll talk about the definition. The electric potential energy of a system of a point charges may be defined as the amount of work done in assembling the charges at their locations by bringing them in from infinity. Okay, I hope you can understand it. I'll repeat it once again. Potential energy is of the system of point charges may be defined as the amount of work done to bring assemble the charges in the required configurations from infinity. Okay, that is your electric potential energy. I hope this is very clear. Please note down the questions. I am speaking the questions. What is meant by electric potential energy of a charge system? I'll repeat the question. What is meant by electric potential energy of a charge system? Okay. And secondly, deduce expressions for potential energy of a system of 2 point charges. Okay. These are two questions which you need to write down. I'll also talk about the system of charges that are more than 2, but we'll talk it in later on lecture. Just now you just need to know the concept of electric potential energy. Okay, I hope you will understand well. If there are any issues, you can message me. All the best, keep studying.